Now today in Algebra 1B we're going to be focused on trig ratios, which means that we're going to finally begin our discussion with sine, cosine, and tangent. Now I'm actually going to write these out here because later on when you start using your calculator, sine is abbreviated SIN on your calculator as a button. Cosine is COS, and tangent is TAN. So you're going to have to be able to keep those in your mind as we're going through this section. So first of all, we're going to start out with just some basic ideas of what trig ratios are about. First of all, if they're a ratio, they have to compare two sides and be a fraction. So when I deal with sine, sine is going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse, and tangent is going to be opposite over adjacent. Now it's easy to look up here and see that that side's hypotenuse. So easy to find these two. That's not going to change no matter what angle we're focused on. But if I have a focus angle that happens to be B, then I'm going to look at the side opposite it to be able to find my opposite. Now I'm actually going to go through an example and show you how to actually label it. So in this problem, actually I'm just going to look at just this first one. I want you to focus on angle A because I'm going to do sine of A, cosine of A, and tangent A. So if this is my focus, if I draw a line out of this angle that I'm focused on, it hits 5. That side's going to be opposite. 13 we know is going to be hypotenuse. So once across the 90-degree angle, longest side of a right triangle. And this side down here is considered to be adjacent. It's adjacent because it shares a common side with angle A. In fact, the side that's 12 long is actually one of the sides of the actual angle for A. So when I actually go through to solve these, let me just move these down a little bit. To do the sine of A, I have to do opposite over hypotenuse. So opposite would be 5. Hypotenuse would be 13. Now I can't reduce that, so that's my final answer. That's my ratio. Now to do cosine, it's adjacent over hypotenuse. Adjacent is 12. Hypotenuse is 13. Can't reduce it at all, so this is my final answer. Now tangent is opposite over adjacent. Opposite is 5. Adjacent is 12. They don't have anything in common, so that's your final answer. So really doing sine, cosine, and tangent is about getting your things labeled correctly. Now in this example, they want us to focus on angle B, which means that this is going to be our focus. So that means that if I draw a line out and hits this side, that's opposite. Makes this adjacent and hypotenuse. Now if I were to look at those two triangles that are up there, for example 1 and example 2, hypotenuse has been the same for both of them. But depending on what your focus angle is determines what's opposite and what's adjacent. So sine of B is opposite over hypotenuse. So opposite would be 12, hypotenuse is 13. And that's it. Cosine is adjacent over hypotenuse. So adjacent is 5, hypotenuse is 13. To do the tangent is going to be opposite over adjacent. Opposite is 12 and adjacent is 5. Now just for a minute, let's look at relationships. If it's the same triangle in different focus angles, notice that these two are exactly alike. And these two are exactly alike. And what's the relationship that you see here? In mathematical terms, we would say that those are reciprocals. So whatever this is on the first one, the flipped over version is going to be what happens here. Okay, now, the next thing, doing sine of 50, cosine of 50, tangent of 50. Those are simply just putting them in your calculator. So you're going to push the sine button and then 50, and then you're going to close your parentheses and hit equals. Now most of these they usually do to 4 decimal places. So if I round, it's going to be this. Now if you go home and do this in your calculator and don't get this answer, I would look in the mode in your calculator, make sure you have the degrees turned on and not the radians, because that can be a problem. So the cosine of 50 be 0.6428. Tangent of 50, 1.1918. So all of these problems you want to go to the 4th decimal place. Okay, now, example number 4 is a little bit about how you can use this. So in this one you can see this must be my focus angle. Makes this opposite. 12 happens to be hypotenuse, and this would be adjacent. So if I'm looking at the sides that actually have information on them, hypotenuse and opposite would be that one, which means that I'm going to have to use sine is opposite over hypotenuse to solve this. So the sine of 35 degrees equals opposite over hypotenuse, which is 12. Now if I put these over 1, I can just cross multiply. So 1 times x is x. The other directions could be 12 times the sine of 35. Now it's really important that if you do a number, like it's 12, that 12 has to go out in front. Okay, so 12 sine of 35 so I get x equals 6.8829, keeps going. Now most people, you're going to be able to round to 6.9 if it's just a side length. And that'll be your answer.